Okay. Awesome. Rock and roll. Okay, so welcome back, everybody. All right, so welcome back. I'm glad everyone had a good weekend. Our adventure in computer graphics continues this week. You know, last week we spent almost all of our time and energy talking significantly about the material workflow inside of Maya and looking at materials and light characteristics and really beginning to pull the veil back from the rendering engine a little bit. We're going to continue this process over the next couple of weeks. It's an ongoing, I don't want to say struggle, but it is definitely a significant challenge, right? We have very conceptual, weird, wacky tools to work with, right? You know, not only are we working inside of a true three-dimensional space, but we now have to kind of manage a really intense rendering engine that has a direct impact as to specifically what our audience is going to work with, right? It's tough. What you see in the viewport is not at all what's going to show up in the final render, and as we've discussed before, it's really all about what shows up in the final render. This is a journey, right? So be patient with yourselves as you walk through this journey. It is tough. It is hard. There is a lot of technology that we have to wrangle and be really kind of mediocre at to create some really kind of good images, okay? So hang in there. This week, we're going to get back into our modeling chops a little bit and really continue to explore a new facet of our 3D modeling pipeline called Subdivision Surfaces. In this, we're going to talk about, specifically, we're going to be making a cannon, that cannon right there. And if you look very closely at this model, what don't you see structurally, geometrically? Polygons. You don't see the telltale signs of those faceted edges that is usually the hallmark of a polygonal object. So subdivision surfaces allow us to take a basic geometric mesh, and then I hesitate, okay? I hesitate to say it smooths it out, but that's kind of what it does, right? It puts the entire mesh under what I perceive in my imagination tension, and it pulls all of our surfaces, and it creates a very tight envelope around a control cage. It's pretty neat. It's cutting-edge technology. It really is the foundation for all computer graphics of the television and feature film world. So we're going to spend some time today looking at how we can leverage this technology here in Maya, how we can render it, and some really important modeling ideas that we need to have command on to control the algorithm, because that's really what we're doing. We're applying a really cool, fancy algorithm that smooths the shape, okay? We have two big objectives this week. The cannon is going to be our homework. We're going to come back to that here in a minute. And then we also have a little medicine bottle, too. And our medicine bottle is really for us to kind of continue to build and work off of today, okay? This is going to be our assignment here in about an hour or so. We're going to build a simple medicine bottle. But once again, if you look at the render here, okay, what don't you see? Polygons, right? We don't have those faceted edges. So we're going to look at how we can apply that subdivision surface algorithm to get these really cool geometric shapes, okay? We're also, and this is usually where the train kind of derails for some folks, we're also going to look at a new rendering engine, okay? I know we've been spending a lot of time looking at the Maya software rendering engine last week, and that's an important framework and foundation to set, which leads us into Mental Ray, the rendering engine which we're going to be hanging out in pretty much for the remainder of the semester, okay? Mental Ray is a really powerful rendering engine. It comes with every version of Maya 2016. It's on your computers. It's not, and it's an interesting environment, let's put it that way, okay? It's going to allow us to create some really cool photorealistic effects pretty quickly. It has its own series of materials and shaders that we'll need to apply to ensure that we're getting what we're after. But most importantly, it really allows us to participate in our subdivision surface pipeline in a direct way, okay? So it's pretty great. So we're going to be looking at sub-Ds, and we're going to begin, and I want you to underscore in your mind, begin the conversation of working with Mental Ray today, okay? And I think once you see the results that we're able to achieve in Mental Ray, you're not going to go back, right? Because it's pretty fantastic, right? The Maya software engine is kind of the original software rendering engine from that was developed way back in the mid-90s. They haven't added a whole lot to it. Some new shaders, that's kind of it. They really, Autodesk has really relied on the developments of third-party rendering engines like Mental Ray and Arnold going forward, right? Because in 2017, Autodesk has kind of said goodbye to Mental Ray as the default bundled rendering engine. It's still there and supported and available for folks to use, okay? But now, in 2017, we have a new rendering engine called Arnold, which is pretty fantastic. Yeah. All right, let's jump in and start looking at some ideas here, okay? All right, as with everything, let's jump back over into Maya real fast. And let's start with some big picture ideas. Mariana, would you just dim the lights, please, as you masterfully has done the last couple weeks? Thank you. Okay, so if you take a look at what we've been working with in Maya so far, these polygonal structures have had some pretty direct limitations to them. Check it out. Let me show you what I'm talking about. If I create a polygonal cylinder, let's zoom in here real fast. Take a look-see. Dun, da, da, da. There it is. There's our polygonal cylinder. How can I change the resolution of all the polygons going around the circumference of our cylinder? Pop quiz today. I should issue a pop quiz. I say it all the time. I should actually do it one time. Why not? That'd be fun, right? To see you guys sweat a little bit, right? I don't have to, right? Yeah, okay. So how can I go in and change the number of polygons that are going around my cylinder? What am I looking for specifically? You're in the ballpark, you just don't know what it's called, and that's okay. Yeah, okay. Yeah, there we go. Okay, so specifically we need to go look at some attributes, right? And there's a couple places that we can find these attributes, but 9 times out of 10, the easiest place to find these attributes is just to go not into your tool settings, but into your channel box, right? Your channel box is going to give you a whole bunch of stuff, and specifically, there it is. All of our inputs, okay? Because to create this shape, there is an input series of code, if you will, a small little bit of programming that determines how the shape is created. And specifically, if we go in, we can start changing, the subdivision axis, which is going to determine the number of polygons that are going around the outside of our cylinder. Increasing and decreasing this value. There we go. Come on now. Sorry. My brain is just not working today. Okay, so if I increase and decrease that value, so it's at 20 at the moment, so if I put this down to like 12, you can see what we get, right? The number of polygons that are being drawn on this cylinder is drastically reduced. Now, inside of the world of feature film effects, we want to be able to optimize the number of polygons that are flowing into our model itself. We don't want to have a zillion polygons, right? That's not a good practice. It's going to bog down the render. It's going to make the texturing and the shading process very difficult. And it's all going to just have a negative effect on the overall performance of this object inside of our three-dimensional scene. Being able to change the level of optimization of our meshes is really important. Access to these input nodes allow us to do it at the input level. However, there are some other ways of working inside of this system, okay? Because what we're seeing here are true polygonal shapes, faces, right? And the number of faces that cruise across the surfaces of our model has a direct impact on the perceived quality of that surface, right? More being higher quality, less being lower quality, right? If you go back into like the PS2 era of video game graphics, all the cylinders were like this, right? You could actually see the faceted edges, right? And it definitely didn't suspend disbelief. And if you look at the modern day video game architecture and what you see in feature films, you don't see any of those, right? It's actually really quite staggering how far we've come in the real-time world. Last week we took a small little glimpse into the future of VR technology when it comes to computer graphics. And the role of real-time rendering is becoming much, much more important inside of the future of all computer graphics, right? I mean, shoot, I'm a big, you guys ever play the game Red Dead Redemption, the Western? One of my favorite franchises, right? For me, personally, it's on the Mount Rushmore of favorite video games. And, they're having the sequel come out next year, and it looks amazing. Here, I probably shouldn't do this since I'm live streaming, but whatevers. I'm going to do it anyways, right? Okay, so let's see. I'm going to... I'm not showing anything that's not already online, so. Okay. So this is the trailer for the next Red Dead Redemption game. And it's pretty cool. I won't play with the sound because that's not the point. I'll let you guys kind of check it out on your own. But I want you just to look at the visual quality that's coming out of a real-time rendering engine. Okay? This is all in-game footage, which is just mind-boggling, right? It's pretty cool. It's photographic. It's photographic. And there's one part here in the trailer for the video game that we're going to stop and look at directly, because it kind of illustrates why we need to have control over the quality of our meshes. And the subdivision surface algorithm allows us to control the perceived resolution. And it's that one right there. Okay? Take a look at this, right? Take a look at this. If you just consider the density of information that's being drawn in this one frame, it's kind of staggering, is it not? Okay? How many individual models are we seeing in this one environment? And this is clearly a much larger town, right? So we're seeing the general store in a very large, very large model and very large set piece. So just in this one exterior shot, let's just take a guess. Let's count real fast how many individual models we see here. Should we do it, right? I'm not even going to do the characters, okay? We're just going to ignore the characters and just look at what's classically referred to as sets and props, okay? So we have, okay, and this is, I love doing this, by the way. You got 1 piece of garbage, 2, 3, 4, 5, 6, 7 for the telephone pole, right? We're going to ignore this guy, ignore this young lady. 8, 9, 10. I'm going to guess that maybe that there's like 3 different apples in here, and then they duplicate them over and over and over again. So that's what we're at probably, we'll just call it 11, 12, 13, the little washboards inside the basin, okay, 13, 14, different barrel, right? Yeah, if you look at those barrels, they're different. 14, same apples, so I can't count those again. 15, 16, 17, 18, yeah, 19. All the ropes over there is 20. The signs on the door is 21. There's a bench there. There's a sign right there. I mean, it's just the number of sheer models in one frame is staggering. And I haven't even counted the building, nor have we really taken a look on the inside of the building, which probably has a couple hundred other more models in there, right? So being able to control the quality of our models is important going forward, because now we're participating in a world where the density of data has skyrocketed, right? It's skyrocketed. Rendering a frame like this in the previous generation of real-time rendering graphics, or even just feature film visual effects, would have just not been possible. Not possible at all, right? So let's jump back over into Maya real fast and talk about how we can continue to optimize our scenes without having to add more geometry, right? Because what we are trying to avoid in a lot of situations here is doing this. Because now we have a bunch of geometry, right? Of course, I can just kind of peg that subdivision axis and just add a lot of information in there. And in some situations, this is okay, right? But there are other tools inside of our toolbox that will allow us to achieve this result without having to throw in, just a tremendous amount of geometry in here. Because we don't have 60 polygons on this mesh, right? How many polygons do I have for a cylinder? 180. 180 surfaces to describe that object. What if I told you I can do the exact same thing with 14? Cool, huh? Cool, huh? Thus enter the role of subdivision surfaces. Okay? Let's take a look at it real fast. Okay? Subdivision surfaces are pretty neat. It's actually a system that's built into Maya as part of our core architecture. FYI, sub-Ds are not anything new. This is not technology that's the latest and greatest. It's kind of the foundation of everything that we've been working with inside of computer graphics going all the way back to the mid-'80s. Okay, we have one person to think. Actually, we have 2 people to think. And that's Ed Catmull and Ollie Clark, okay? Those 2 guys are the original researchers that came up with the algorithm that defined the smoothing at the University of Utah, And in every sense, they're the grandfathers of the computer graphics world. They really are. They created texture mapping, okay? The idea of projecting an image onto a polygon. They came up with the science that allowed us to do that. They came up with the science of subdivision surfaces, okay? Sub-Ds is at the architecture, or it is the core architecture of a modern feature film production pipeline, okay? This stuff goes all the way back to the mid-'80s, and Ed Catmull is kind of the, he's the epicenter of the computer graphics world, okay, for the most part. He's the big thinker, the scientist that came up with all this jazz. And he's now the president of Pixar, okay? He's one of the 3 founding members of Pixar, right? He was the computer nerd that created all the technology that allowed Pixar to do their thing, right? Who are the other 2? John Lasseter, who was the animator, right? Because you got Ed Catmull, who was the computer scientist. You have John Lasseter, who was the animator, right? Then who's the last person? Steve Jobs, right? A lot of folks forget about Steve. Who did Steve? I love this kind of contextual history of Pixar, right? Because Pixar continues to this very day to be an active developer of our technology. They get a lot of credit for making really amazing feature films, but they have a really intense computer graphics group at Pixar that is, inventing new ways of making these graphics come to life in front of us, right? But I love where they began. Does anyone know who Steve Jobs bought Pixar from? This is really kind of funny. He bought it from George Lucas. Yeah, cool, huh? Yeah, Pixar was actually the original computer graphics group at Industrial Light and Magic, the guys and gals that make all the really cool special effects for like Star Wars and what have you, right? And the computer graphics group at ILM did some really amazing work, cutting edge, right? But George was really most interested in the hardware and software that they created, okay? Because he wanted to continue to roll that into Industrial Light and Magic and make really cool visual effects for feature films. But the core members of that group said, hey, we want to make films. We want to make computer animated films. That's what we want to do. That's all we really want to focus on. And George says, that's cool. I don't have any problem with that, but that's really not aligned with my interests. So I'm going to sell you guys off to an investor, and maybe you guys can go off and make films, but I'm going to retain all the intellectual property that you guys created here within inside my group, and kind of thus gave birth to the computer side of Industrial Light and Magic. Okay, so he sold Pixar to Steve Jobs, which is kind of fun, right? Does anyone know why it's called Pixar? I think it's really kind of great. Pixar was the name of the machine that rendered all of their graphics. It was the Pixar box. And originally, Pixar didn't make films. For the first couple of years, Pixar tried to sell computers. That was what they did for the first couple of years. They tried to sell that machine, that computer graphics box, to people all around the world, and they failed miserably at it because no one wanted to spend $250,000 on a computer in those days, right? And so finally, Steve said, why don't we try making our own content here, and maybe we can get some, maybe we can attract like Disney to invest in us or give us some seed money to grow our studio and really start making content, right? And then the rest is kind of history from there. So this core technology was really built in that era, in the early 80s, and applied to all the early Pixar films. Okay? Subdivision Surfaces has been around forever, and they're pretty fantastic. I want to reduce my subdivision axis once again here back down to 12. Okay, there we go. And let's look at this in play. Okay, because right now, if you look at this object sitting inside of Maya here, it's very faceted. And the idea is that we smooth out the shape in a non-destructive way. Okay? Now, I don't want anyone to be confused here because there's actually a smooth command. Okay? So, or I never use it because I don't know why anyone would want, here it is, smooth, right? You can actually smooth out the mesh, okay? Smooth out the mesh, and that's a destructive edit, okay? It's physically going to change your model. It's going to add geometry. Yeah, it's going to smooth it out, right? Doesn't look too hot, and to get the results thereafter, you have to continue to go in, and maybe we smooth it again, right? And you can smooth and smooth and smooth and smooth and smooth, and continue to kind of iron out your shape, right? But this is destructive. There's a point of no return. If I were to delete all of my input nodes inside this object, I would be stuck with this mesh, and that makes this mesh kind of not usable inside of the larger context of a production pipeline, right? As good artists and engineers, we always have to produce something that's editable, right? Because inevitably, at the 11th hour, when you think you're done, you're going to have a boss, a director, another engineer come in and say, hey, we need to make a change to this. So we have to be editable, right? We have to be flexible in how we generate our objects. This is not flexible. This is very rigid, right? Me no likey smooth, the mesh edit smooth command. That's just not something that I would encourage anyone to do, especially in the modern day architecture of subdivision surfaces. A lot of folks, they see subdivision surfaces, but they don't understand how to use it and wrangle them. So let's kind of bring back this object here and look at how we can wrangle them and how we can take advantage of this algorithm to get what we want. Now, the application of this algorithm, believe it or not, has been in front of you the entire time, unbeknownst to you. If you hit the 1 key on your keyboard, you can see that nothing really changes. However, if you hit the 2 key on your keyboard, we can see a small, simple little preview of the subdivision surface algorithm. And then if you hit the 3 key on your keyboard, that control cage, that green outline of our mesh goes away, and what we see is just the true subdivided shape, okay? Welcome to subdivision surfaces, okay? If I was to deselect that object, now if you look closely at what we're creating here, it's starting to smooth out. However, this is non-destructive. I haven't changed the actual polygonal layout of this object. I can always return, I gotta select it first. I can always hit the 1 key again, and boop, there's my original shape again, okay? So what this does, it allows us to smooth the shape, but in a controllable way, and in a non-destructive way. Let me show you what I'm talking about, okay? So let's reapply the algorithm once again and take a look-see at kind of what's happening here. Now, in my imagination, we're putting the entire surface under tension. Imagine in the center of this object, there's a little miniature black hole, right? Any astronomy nerds out there? I love astronomy, right? It's good stuff, right? What is a black hole? What does a black hole do? Maybe go watch the movie Interstellar if you want to get a master class in black holes, right? It's kind of really cool. But a black hole is going to pull light into it, right? It's like a gigantic vacuum cleaner. It sucks in everything into one spot, right? So in my imagination, there's a miniature black hole on the inside of my mesh, and all of my polygons are being, of course, influenced by that black hole, and everything is being pulled into the center, right? The edges of our polygons begin to bend and deform. Get a comment?
I might be jumping ahead here, but like in the beginning of the quarter, when we accidentally did that, when you went to render it though, it went back to being.
Yeah, absolutely, and we are going to get to that. So this is the big problem at the moment. We hit the render button, and you go, what? This is not cool, right? So we'll come back to that in a minute. Something that we can easily overcome by changing our rendering engine, because the Maya software rendering engine just doesn't understand subdivision surfaces. The Maya software rendering engine wants us to convert our object from a polygonal shape into a subdivision surface, and that kind of defeats the whole purpose of making a non-destructive edit on our mesh. So we'll come back to that. All right. So there's an entire little miniature black hole on the inside of our object, and all the polygons are physically now bending and deforming. What used to be a flat planar shape is now curving a little bit as it kind of goes under tension across the entire surface. Okay. Now we want this deformation, but we want to be able to control it a little bit. Okay. This tension is exactly what we're after because it smooths out the geometry of our mesh, but we need to be able to go in and say and determine how much of an influence the algorithm is having on certain parts of our object, okay? So perhaps the goal of this particular cylinder is just to smooth out the sides, but to get the top of our mesh relatively flat still. At the moment, if you look at the top of our geometry, it's kind of turned into a capsule, okay? And we get these lovely kind of cusps in there. If you look carefully here, you can see where it's kind of dipping like that. That's not good, right? We have some work in here that we need to continue to go in and do to get the result that we're after, okay? Controlling our mesh is not a difficult thing. It's pretty easy. but it does require us to understand some basic principles of how this algorithm is working inside of our scene. Now, I could, if I wanted, and I don't think you want me to go into the math behind this. There is some hardcore computer science that's determining how all these points are, are moving and deforming on our mesh. But trust me, I don't think anyone's interested in that. To a certain degree, I'm not interested in that. I just want to see the results. Okay. But if you think about it, what we need to add some additional geometry in very specific areas to control and influence how the algorithm is deforming our mesh. Okay. So let's return to the original here for a second and understand the goal. Because I think that's probably the best place to start when really trying to look at how to apply some additional geometry into our scene and how to control the algorithm itself. The goal is to keep the top of our cylinder perfectly flat, but have the algorithm smooth the sides. Okay? In every sense, what we need to generate here is still that kind of sharp plane change from the top of our cylinder to the sides of our cylinder. Okay? So if I was to draw this on the board here, and I apologize having to eliminate this lovely artwork. That's a cool chicken, by the way. Okay, so if you really consider what we're trying to achieve here, this is the side of our cylinder. I still want to have this plane change, 90-degree plane change right here. Right now, the Subd algorithm is producing something like this, which isn't what we want. We want to shore up this edge, kind of sharpen the corners a little bit. We can easily do so by going in and adding additional geometry. Okay? So the idea here is real simple. Whenever there's a plane change where we want to influence the impact of the algorithm, we need to add edge loops, okay? And specifically, we need to add 2 more edge loops, okay? So if we return to our example here on the board, dun, 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 okay, this right here, this vert is going to represent the original edge loop, okay? That's the original edge loop. What we need to add is an edge loop above and an edge loop below. Okay? So if we were looking at this object inside of a true kind of perspective environment, and I'm doing this freehand and very quickly here. Okay, so there's the top of our cylinder. What we need to add into our cylinder is an edge loop that goes like this, all the way around the top. And an additional edge loop below the original, something like that. Okay? In every sense, in my imagination, what I'm doing here is sandwiching the original edge with 2 new edge loops. Okay? One above and one below. Yes, ma'am?
How's that different from the bevel?
Well, it's not that it's different, because we are going in and adding edges, right? Because that's the focus of the bevel tool, is to add edges and change the radius. Okay? But what the bevel tool doesn't do is smooth out all the circumference polygons, right? It only changes the quality of the edge transition, right? So let me just illustrate that again real fast in my example. So if I went in and selected some edges here, okay, yeah, I could go in and very quickly just grab the bevel tool, increase the segments, but I'm only influencing the quality of the mesh right at that plane change, okay? I want to influence the quality of these polygons too, okay? We'll go back in time a couple steps, get rid of that input. There we go. Okay. So how do we do this? Okay, because we need to go in and add an edge loop in here and down here. Okay. Now there are a zillion ways that you can do this. Let's look at a couple. Okay. Using the tools that we already kind of had exposure to, we can very quickly get the desired result. Let's start at the top here. And I'm going to select some faces. Just triple check, make sure I got the ones I want. Yep, I'm pretty good. Okay. Now, one of the things that we can do up here at the top is just run the Extrude Tool, right? Because the Extrude Tool has this really great local translate. Oops, excuse me, not local translate Z, I meant offset, okay? Let's put this at 0.05 because we just want a very small offset there. There we go. If you look at what that offset channel has done on the extrude command, it's given us that second row, okay? Part 1 done, right? We've added in our first row, our first new edge loop above, okay? Now, we can also do that exact same thing very quickly and easily, and I'm going to use the drag style now for these down here. Fire off extrude. I'm just going to do an offset. And what did I think I did 0.05, so we'll do something similar. There we go. And look at what we've generated. Okay. Fantastic, huh? Let's see what happens now if we return to object mode and hit the 3 key on our number pad. Ha ha ha! Look at that! Boom shakalaka. Okay? We've controlled the impact of the algorithm. Before, without those 2 edges in there, without those 2 edge loops in there, excuse me, the entire top of our surface was being rounded out, right? Kind of transforming into a capsule. Here, let me do this. I have another way of illustrating this for you guys. Go. Here, let's put. There it is. Okay. So if I subdivide, so this is how far we've come, right? This is the original shape. The original just kind of unit cylinder. We've added a couple edge loops and subdivided it, and boom, looking pretty good, right? This is something that we're after. This has my attention now, because now we can very easily and quickly go in, add edge loops, and control the impact of the algorithm. Now, really what's kind of happening here is that when there's a very tight collection of edges, the algorithm is still at play, but it's not having a sweeping effect across the totality of our surface, right? It's kind of almost being turned off just at that plane change, okay? Which is what we want, right? Where the impact of the algorithm is not felt across the entire surface because of the distance between all these little edge loops here, right? The distance between this edge loop and this edge loop is pretty small, right? It's pretty small, okay? So the impact of the algorithm is not as visibly intense as it is in this section in here, okay? Questions on this so far? Because we've only scratched the surface here on what we're able to do with subdivision surface algorithms. Okay. Let's keep going then. Let's keep going. Okay, so if we return back to our example here, hit the 1 key to return to our original polygonal mesh. I have some work down here at the bottom that I need to continue to do to really kind of shore up all of these edges, okay? What do I need to add at the bottom of my mesh to get what I'm after? Offset. So that's the channel in the tool that we're going to use. But think about what we're trying to achieve. What are we trying to gain here? What are we trying to place on the mesh? Because sometimes that's the hard part, right? Figuring out what tools we are going to use, that's the easy part. But what are we trying to achieve here? An additional edge loop, right? Because in order to shore up that transition between the bottom of our surface and the sides of our cylinder, we need to have 3 edge loops, right? This one right here, this is the original edge loop that defines the surface transition itself. In the previous operation, we extruded those interior shapes, and we gained this one up at the top. Now we need to add a 3rd one in down at the bottom to get the result that we're after. Excuse me, I just sneezed. I apologize for the folks that watching the live stream I wish I had a sneeze button, right? They have those at radio stations, right? They have a cough button. Just temporarily turn off your mic for 2 seconds while you hold the button and cough. I wish I had one of those. Okay, so earlier we were able to go in and just very quickly, oops, there we go, very quickly select some polygons, and the offset channel in the Extrude Tool really gave us what we're after. Let's do 0.05 again so that we're kind of uniform in our application of the tool here. And if we take a step back and look at what we've created, There it is. Geometrically, that is the exact same shape that we started with, right? We've only added interior edge loops, so the volume, the overall proportions of this total object is the same as this one over here. They are identical. Well, let me make this one identical because I did change the inputs. Now they are identical, okay? Identical cylinders, okay? Identical cylinders. However, when we start subdividing them, that geometry that we added allows us to control the impact of that sub-D algorithm on our surface, okay? Pretty cool, huh? Pretty cool. It's a really neat system. It allows us to create some very, very stunning results. Something that we can and should look to apply on just about everything, right? Now, we've been working with cylinders up until now, but if we take a step back and look at how we can control and influence this on, like, let's say a square, it's not too different, right? Let's do it real fast. I'm going to grab these and just move them out of the way. Okay. Let's add in a square into the mix. Oops. Wonderful. So we still have to do the exact same thing for the square. If I was to hit the 3 key with my square selected, we now get what's commonly referred to as a quad ball, right? Not what we want, okay? I still want to be able to go in and, still want to be able to go in and have it generally look like a square. Maybe we have the corners just a little bit sharper, okay? The 1 key on our keyboard will unsubdivide our mesh. And technically, if you think about it, what we're doing here is we're actually previewing the subdivision level, okay? If we go back to the unsubdivided mesh, what do we need to add in here to shore up those transitions and create a subdivided cube that generally looks like a cube still? Edges, edge loops. Yeah, edge loop is all about edges, right? So let's focus on this loop in here. Okay, so this between this plane up at the top and this loop over here, what do we need to add? Edge loops, right? Yeah, absolutely, edge loops. And earlier in the quarter, we talked about what a loop is. Help me out. What in the world is a loop of geometry? Oh, you should be happy I'm not giving you guys a pop quiz today. Maybe I should. No, I'm not going to. A loop is a row of polygons or edges that wraps all the way around the mesh and connects back onto itself, right? So we need to add a loop of edges inside of our scene to influence the impact of our algorithm. Now, if this is the original shape or the original transition, and I cannot click on things today. There we go. Okay, if that's the original, what's the goal here? What are we trying to infuse on the mesh? Say again? Well, the result, the visual result is going to look rounded. Okay? We're trying to add a new loop above the original. Okay? And then a third loop of edges below the original. Go back to our illustration on the board here. This arrow is the original one, right? The corner of our cube. We need to have a new one above and a new one below. It's an edge sandwich, okay? An edge loop sandwich. So how can we do that with a cube? It's pretty easy with a cylinder. But how can we do that with a cube? Interesting question, right? Interesting question. How can we do it with a cube? Because the extrude command, we were doing it on a single surface before. So if I went in and selected that top cube, and I ran extrude, and once again just did a very small offset. Okay. If I did that on each one of these surfaces over here, I would get a really odd result. Okay. Now, technically, we're getting the result that we're after here, but these little mitered corners are a big problem for us, okay? Oops, I apologize. Okay, these corners in here are big-time problems for us. We can't have those, okay? We need this edge to go around the corner here, connect back onto its friend over here. So this method of infusing our model with additional edge loops using the extrude command isn't necessarily the best one, okay? We can go back in, we can continue to slice our mesh up to get what we're after, but there's an easier way of getting the loops that we're after, okay? So I'm going to hit the undo command a couple steps here. Get rid of all that jazz. Okay, there we go. Okay, and let me show you a really cool tool. And it's under the mesh tools. Okay, at the top of the screen. And please remember that in order to get to this pull-down menu, you have to be in the modeling selection of menus. Okay, so this tab right here changes all the top-level menus inside the interface. So I'm in my modeling menus. So it's under Mesh Tools, and we're going to do Insert Edge Loop. Okay? Insert Edge Loop. Now, what this is going to do is that it's going to allow us to go in and left-click and drag on an existing edge. And that dotted line represents where our new edge loop is going to go. Okay? The tool is still active, so I'm free to go in and start adding edge loops into my model. You can see they can very quickly do this and get the results that I'm after. I got 2 more that I got to do. There you go, and I'm done. So I'll hit the Q key to go back to my selection tool. And let's just inspect our mesh. Things are looking good. Look very carefully at what we've created here. Ooh, a little too close. Look very carefully at what we've created here. Okay. Here's the original surface, right? The original boundary of those planes, right? I've added one above and one below. Okay. Let's see what happens. Let's go back into object mode. So F8 on the keyboard and then hit the number 3 key. And ooh, cool, huh? Let's zoom out some. A little too close at the moment. Yeah. We like you very much. Okay. This is pretty neat. Now, the cool thing about this is that, of course, it's smoothing out our shape a little bit. Okay? Smoothing out our shape. We're getting nice little radiuses in there, which is pretty fantastic. But this is non-destructive. Okay? So I can go back in and change or maybe even delete these loops at any time. This is the purpose behind working inside of SubDs, is that I get to change the impact of the algorithm at any level by moving these loops around. Okay? So let's pretend I'm making my little cube here, the most award-winning model on the face of the planet. Give me the Academy Award now, right? Oscars are coming up here soon. Anyone excited about the Oscars? Yeah, I used to be really into the Oscars, and then I started having kids, and I think I've gone to the movies like twice. And one of those times was to go see Rogue One, okay? Because I'm a huge Star Wars nerd. So perhaps my creative director comes in and says, Pat, I need to have that radius at the corners here bigger. It's too small at the moment. So all he or she sees is that, and they go, this is cool, I love that, that's really neat, but I need it to be bigger. I want it to be a much bigger radius. Now, if I was using traditional modeling tools, okay, maybe the Bevel Tool, okay, I would then have to go back into my inputs, make some changes, and at times, and I haven't shown you guys this yet, but at times you want, if not need and are required to delete all of your input nodes, okay, on your meshes. That happens often, actually, right? So there's a very good possibility that, in my little example here, those input nodes just aren't available, okay? So what am I to do, right? If I don't have access to the input node that physically beveled and rounded those edges, I am up a creek without a paddle, right? Because in every sense, this is a back to formula moment where I have to rip apart my mesh and rebuild it, okay? That's a bad day, okay? However, with subdivision surfaces, the quality of that radius is defined by the proximity of those edges. Let me show you what I'm talking about. I'm going to unsubdivide my mesh, and and I'm going to hit the F10 key to go into my edge selection mode. Okay, I'm just going to start grabbing that one. If you look very carefully at the edge loop that I've grabbed, it goes all the way around the mesh. Rock and roll. And now, with that thing selected and in tow, here's what I'm going to do. I'm going to move it back pretty significantly. Okay? Do the same for this one here. I'll move it down. Grab this one. Here's a great old trick, by the way. If you grab two of them, you can scale them closer to each other. Okay, so you don't have to move them. Scaling them along a specific axis will grow that. We'll kind of grow them inside. Okay, there we go. Oh, someone had this question last week, and I think it's really important to point out. The question was, I can't double-click on stuff. I can't double-click on an edge to grab a loop. What's the solution to that problem? It's an easy solution. Well, it's going to be double left-click, right? But if you're not, if you're, let's say you go in, you're trying to select something, and you can't. Of course, it's making a liar out of me today because it's doing it every time. But I've seen this before. I've even experienced it before, where I just can't grab a loop. Okay, even when I know I can visibly see that there's one there. Here's the trick: just make sure you're in the selection tool. Okay, the selection tool. At the moment, what tool is active inside of my scene? The move tool. Okay, and that can at times have a negative impact on our ability to select loop geometry. Okay, if you're in the selection tool, whoop. Also make sure that you are in the marquee selection tool property. Okay, if you're in drag, sometimes this doesn't allow you to do it. Okay. Yeah. So double click, hold down the shift key, double click on the other one. Yep. The shift key is always going to be the keyboard modifier to add a component selection into an existing selection. All right, so let's get out of here real fast. A small little deviation. F8 on the keyboard to return to object mode. And now watch what happens when I hit the 3 key on our keyboard. Interesting, huh? That radius has now changed. It used to be real tight. Now it's much bigger. So by spacing out these edges, we're having a direct impact on how the algorithm is influencing our mesh, right? Yes, sir?
So, like, I can't move the edges without the cube moving with it. You know, like it's changing.
Well, that's odd. Let's check it out.
You see how, like, it's bringing the cube with it?
Oh, yeah. Well, you can't go past that, the boundary edge, right? Here's what I would do. Go back into your selection tool. Okay, now double click on that edge. See how it grabs the entire loop?
Yeah.
Now move it. Now we can only move it that way.
All right.
Yeah. If we moved it the other way, it would go past the boundary and it would destroy the mesh.
All right.
Yeah.
Thank you.
Pretty cool, huh? Now, when we pair this with kind of an advanced modeling operation, we can generate some pretty great results quickly, okay? And controllable results. Results that are not completely paired to our input nodes, okay? Since we're just adding edges that we can easily and quickly delete, we create a very editable mesh at any level, right? And a mesh that we can use inside of the feature film world, right? Where resolution is something that's really not considered too much, and an art asset that we can work inside of a real-time rendering world, okay? Which is also important, okay? All right. Let's take a look at this for a second here. Things are looking quite nice. You can even make some changes while you're subdivided, which is kind of nice. Get a nice cool preview of how it's impacting our scene. Sharpen up that corner. Move it around, sharpen it up that way. Good stuff, huh? Pretty cool. Yeah, it's real easy. Just make sure, for me, what I'm doing is that I'm choosing to work, whenever I'm selecting something, I'm hitting the Q key to fire off the selection tool, okay? And then with the selection tool enabled, you should be able to go back down into your mesh, and simply double left-clicking on an edge loop should select its entirety of its loop, okay? Now, if it doesn't, here's a trick, okay? Now, let's pretend that I'm grabbing this one and I'm just like double clicking and it's not working. Grab that one and then was the left or right arrow key on your keyboard, and that will select the loop for you. Oh, another sneeze. Oh, I jinxed it. Oh, I hate moments like that, right? Gosh. Did I answer your question? Great, rock and roll. Okay, so what's cool about this is that we can continue to pair this entire idea with our existing modeling workflow, but generate some results that are pretty good looking, okay? Generate some results where there's really no apparent visualization of those faceted edges. Let's get rid of my cube real fast. Okay, so there's the one that I was subdividing before. Let's just do this, okay? Put this back at the origin of the scene, okay? And let's just do some simple modeling here, okay? I'm going to hit the F11 key on my keyboard to grab and select some. Oops, let's turn back. I really like that drag selection mode. It's kind of like my favorite. There we go. My brain can work today. Come on, fingers. There we go. All right. So now we can just run extrude. And let's do some offsets. We're just going to do some box modeling here. Hit the G key to reapply the extrude tool, right? And I'm going to create a doohickey. I have no idea what I'm making here. This is, in fact, a doohickey. That's the official technical terminology here. Perhaps I'm modeling some sort of detailed pipe. Too much there. We'll do one more. One more little detail here on the top. Oops. Yeah, we'll call that done. Okay, there it is. Drop the tool by hitting the Q key, and there it is, right? I don't know what that is. It's just a thing, right? And I'm being a 3D modeler now, and I really hate what I created down here at the bottom. So let me just fix it real fast. Okay. Grab some loops. And let's just run bevel. That's good. The same thing on this one. Oops, wrong button. Many apologies. Fraction is way too big. There we go. All right, so there's my object. Now, this is an okay shape. I don't know what this is. It's, like I said, it is in fact a doohickey, right? But what if I want to go in and very quickly start to round this thing out, smooth it out, right? Because at the moment, this is not great, okay? Polygonally, this doesn't look so good, and at times, if we return to our object's input nodes, okay, because this is the knee-jerk reaction, is like, well, if I wanted just to make it a higher resolution, I'll go back over here into the object's input node, right? Here's polycylinder 2. This is the input node that's responsible for creating the initial shape, right? And I'll just change its subdivision axes to 60, okay? And at times, yeah. Right. And this is the moment where we kind of like, seriously? What is going on, right? So going back in time and re-editing those input nodes, you know, isn't always the best option for us to increase the quality of our mesh, right? Adding edge loops and toggling the influence of that sub-D algorithm is really a great idea. Let's just do it real fast, okay? So as we know and remember from our previous example, if we wanted to shore up some edges and tighten those transitions down, we have to add some edge loops, okay? And there are, as there will always continue to be, a number of ways that we can do this. Give me one way. I want to go in and just grab these. Okay, oops, wrong keyboard shortcuts. There we go. Let's focus our attention right in here, okay, at this transition. So, okay, there's the original boundary edge that I want to change, okay? What do I need to add in this area to get what I'm after? Yeah, and 2 edge loops, right? Where are those edge loops going to go? Top and bottom. Remember, edge loop sandwich, okay? So mesh tools, insert edge loop, and it goes pretty quick. When you're adding these edge loops, don't go like that, okay? When they're like right on top, that's going to cause problems. Put it in, you don't want them really spaced out because that's going to make it, the radius there really kind of curvy. But don't have them so close together that you can't select them, okay? Something like that. And the insert edge loop tool is kind of a good one because we can just very quickly go in and add them manually like this, okay? There it is, looking good. If I was to hit the 3 key, oops, excuse me. Let's go back into object mode. There we go. And now hit the 3 key. Yeah, check it out. Looking pretty great, huh? It smoothed out all those circumference polygons, but the ones that define the plane changes are being tightened with the insertion of those edge loops. Okay? So the insert edge loop command is a great, great, great one. It allows us to very quickly influence our scene, but we have some additional work up here that we need to do. Okay? Let's select it, unsubdivide it. Now, how can we, let's focus on maybe these up here. Okay? How could we go in and very quickly influence these edges in here? And again, we don't get a double-click feature for poly loops like we do with the edge loop to select them. Okay? So if I select just those 3 and then hit the right arrow on my keypad, it selects the entire loop. Okay? So don't forget that the extrude command has this lovely offset, and I'm just going the wrong direction. Let's do, what is it, 0.3? Too much. Let's do 0.25. Not enough. 0.2. Oops, not 2, 0.2. There we go. That'll work for what we're doing. I think I did 2 extrudes at the same time. Let me go back and try that again. Okay. Yeah, for whatever reason, and that might be user error. I got an extra row of polygons in there, but that's okay, because we can fix it. We can always fix it. Yeah. In this particular situation, the Extrude tool did not do what I wanted it to do. So let me go back in time a couple steps. And you'll see me doing this a zillion times, where I'll just select something, and then I'll subdivide it, right? Because sometimes we can go in and very quickly begin to understand what the computer's doing just by looking at the subdivision, okay? I didn't add anything in here, so I have an errant extrude. Let's go into my input, my history here. It's probably most likely that one. Let's delete that node. Yep, it was that one that was causing the problem. I fired off the Extrude tool perhaps on accident without changing any of the values, and that was having a pretty big impact on the mesh. All right, so let's go in and change it again. Let's run the Extrude tool. And now I'll do that 0.2 offset. Now it's still messing up. So we'll just do the insert edge loop tool in this particular moment. Exploring what that one did. Actually, it looks like I maybe had done 2 errant extrudes. Yeah, no, it's not going to work. Okay. So let's do insert edge loop tool in here. Very quickly go in Start laying down those edges. It's a great way just to very quickly get what we're after. Now, we don't have to put an edge loop on every single transition. If you look at what we're working with here, these polygons are pretty fantastic. I want to have a nice little mushroom top radius up here at the top of my little doohickey, so we don't resist the... Oh, did it just crash? No, I hit the F1 key on accident. Don't need the Maya help documentation. There we go. So now, yeah, so we don't have to put edge loops on everything because that's a nice curve, right? That's a great curve. Even go in, perhaps, and continue to work with that curve just by moving it up and down. Or perhaps if I scale that edge up and down, I can have a direct impact on how this mesh looks. Okay? This is the kind of the cool thing about sub-Ds is that the algorithm is influencing the current geometry. And if we change the size, scale, rotation, just the proportions of that geometry, we have a direct impact on what we can create. Okay? Or what the output of all of this is going to be. Okay? Neato, huh? Pretty cool. I tell you what, I've been going for well over an hour and a half now, I think. So let's just, or an hour and 20 minutes. Let's just take a small little 10-minute break. We'll come back in. We'll talk about how we can render these things and how we can continue to work with them. Okay, let's take a break. All right, all right. So before the break, we were just having a grand old time working with, with the subdivision surface algorithm. And I think as I look across the room here, I think you guys are starting to really kind of dig and understand the application of this technology. It's pretty neat. It's kind of, it will be the underpinning of everything that we're going to do going forward, right? We should always be striving to suspend disbelief, and sub-Ds allow us to suspend disbelief pretty quickly, okay? Yeah, they kind of add an extra layer in here, some additional technology that we're going to continue to wrangle into, and a technology that's going to influence our mesh kind of interestingly, okay? But it's worth it in the long run. It really is, okay? Okay, however, there's one more big component here that we have to look at. Okay, and that is naturally, of course, the rendering side. How are we going to work and continue to work with this stuff at the render level? Because if we render as is, and excuse me for a second, I just want to make sure I'm on Maya software. If I were to select my object, hit the 3 key of the number pad, there it is, looking pretty great. But let's just go in and create a simple little preview here of what the render is going to look like. Let's render the scene, and then blink. What? Yeah, no bueno, huh? This isn't what we're after, right? I still want to see that lovely subdivided shape upon render, okay? Now, the Maya software engine doesn't really understand what we're doing right now, okay? It just kind of fundamentally does not, this is to the Maya software rendering engine, this is a preview of the subdivision, okay? In order for us to continue to work with this thing inside of the Maya software rendering side, we have to like edit, and we have to, I do this so infrequently because I'm kind of against it. We have to, where is it? We have to convert to, there we go. Convert selection to, where is it? This is not it. This is how often I do it, because I just am a big believer that we should not have to convert an object, because then it permanently creates a sub-D object. I'm curious now. Why am I not seeing it? It's good that I'm not seeing it, because you should never have to do it. Convert selection. Did I just miss it from this? Vertices to faces. Nope. Okay. Well, that's okay. It doesn't really matter because we don't want to do it anyways, right? So how do we render subdivision surfaces, right? Because the Maya software world is just not going to allow us to do what we're after, right? So we now have to enable a really great rendering engine called Mental Ray. Mental Ray has been around for a long, long time. It's one of the more powerful rendering engines inside of our business. Okay, it's owned by NVIDIA. They do a really great job of managing Mental Ray. It's a great, great, great rendering world. It's incredibly advanced. It opens up Pandora's box on every single level, but there's some good stuff in there. However, the first thing that we need to do is go in and enable it. Now, on these machines, the plugin for Mental Ray is already installed, but if you're going home, if you're working with this on your own personal laptop or you're working somewhere else on campus, you're going to need to go in and check to make sure that Mental Ray has been installed on your machine, okay? So let me show you how to do it. Here's the first thing that you need to do, because the plugin may be installed, but it may not be activated yet. And a lot of these exterior tools that integrate in with Maya are plugins. So let's check it out. If we go into the display option, excuse me, Windows, not display, settings and preferences, and there it is, plugin manager, okay? This is going to be a horrible environment because I'm bad with lists. I really am. Lists are they just don't jive with me. And what we're looking for inside of here, and it's way down here at the bottom, and it just drives me crazy because there are 1,000 better ways to communicate this data. So these are all the plugins and stuff that Maya currently either has loaded or not loaded, okay? If it's checked on, that means it's working and influencing our instance of Maya. However, if we keep cruising, all right, so here's the Bifrost stuff, which is awesome. And then this is what we're looking for. Right there. See, Applications, Autodesk, Mental Ray for Maya 2016, okay? This is the name of the actual bundle itself, Maya 2 MR, which stands for Mental Ray.bundle. You want to make sure that it's loaded in your machine. Everyone just check real fast on your local desktops if this is loaded. So if you missed how I got into your plugin manager, it's under the Windows pull-down menu, Preferences, Plugin Manager. Just triple check real fast on your own local machine to see if this is running. And it's most likely going to be at the bottom of this crazy list. And what you're looking for is this Maya 2mr.bundle. Yeah, if you look very carefully, I'll zoom in so it's a little bit easier to see. This is the row that we're after. Okay. Here's what I do. I look for those big categories.
Should we select the auto load as well?
Yeah, make sure. I always put on auto load. Did it say loaded?
Neither of them are.
Okay, great. So if yours didn't say load, make sure you check load on and also do auto load. That way it will always continue to come back and load. Now, for you guys on laptops, you may need to actually download the installer, okay? Because it no longer comes bundled with it. You have to go download it. So here's what I want you to do. I want you to do a simple Google search for Mental Ray for Maya 2016, and you will find it. Do a simple Google search for Mental Ray for Maya 2016, and I believe it's the first hit. Yeah. That's going to take you on that page. This is where you're going. So for you on the Mac, just download that, and it's an installer. It's free. Just download the installer. You're up and running. Okay? Download, get it, of course, launch the installer and all that jazz. Follow the on-screen prompts, and you can get it done pretty quickly. Yeah, there you go. You're there. You're on the right page. That one right there, because that's the OS X one. Great. Download it, run the installer, and then you'll have to continue. You'll have to go back to this menu inside of Maya and then activate it. Okay, but once you run the installer, it'll put the plugin in the right directory, but then we need to activate it. Okay. All right. So if your computer asked you to turn on Mental Ray, if yours wasn't loaded, okay, make sure check that loaded is is enabled, right? And then restart Maya. Okay. Once you restart Maya, then it will actually load the plugin and be available to you. Uh-oh. Beach ball of doom. Blah, 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 blah. There it goes.
Sweet.
Cool.
And then restart it?
Then restart it. If it didn't say loaded, if the check mark wasn't enabled for loaded, you'll have to load it and then and then also do auto load too. That way it gets loaded every single time you start Maya. Give folks a second here to kind of catch up. And then we'll take a look at how we can activate Maya or enable Mental Ray as the Maya rendering engine. It's really, really easy. Okay, so if you're still catching up, don't worry. We can get you caught up. I want to make sure that everyone else is rocking and rolling here. So how do we enable Mental Ray as the default Maya rendering engine? Because Mental Ray will allow us to take all these subdivision surfaces and it will manage them. Excuse me. It will manage and render them when we hit the render button. But we've got to turn it on first, and we do this by going into our render settings. So of course, here's our render settings. Boop. We open it up. The first thing that we're going to be presented with inside of our render settings is render using, well, we don't want to use the Maya software rendering engine. We want to use Mental Ray. Okay, and there are a lot of different rendering engines out there available to us. Mental Ray is a good one. If you're working in the 2017 version of Maya, you'll have Arnold. Mental Ray is not the default anymore. Arnold is, which is a really great rendering engine. It's pretty fantastic. I would recommend, if you're really into this stuff, to start looking at RenderMan. RenderMan it comes directly from Pixar. It's one of the first big rendering engines that came out of that environment, and they have free academic licenses that you can begin to play and learn with. It's pretty neat. I have RenderMan installed on my laptop for 2017, and it's really, really fun, okay? And it's the exact same tools that they use down at Pixar. I mean, it really is the exact same rendering engine. So it's a little bit more powerful and definitely more advanced in its feature set. But once you learn the basics, it's pretty neat. However, we're going to stick with Mental Ray because it's a really good one to learn, and it's pretty accessible for everyone out there. So once you enable Mental Ray as your rendering engine, you can see that we get a couple different tabs here, and some of these we'll talk about here in a minute. But let's, at the very least, let's just close our render settings and fire off a render. Look, there it is. Okay, so once we enable Mental Ray as our rendering engine, it's going to accept all those subdivision surfaces, right? And it's going to understand in a direct way what all these sub-Ds are and make some pretty pictures, okay? So now we truly are working inside of a non-destructive sub-D workflow, because I can go back in and select my mesh, hit the 1 key. I can make some pretty wholesale changes to this. You know, for example, maybe I want to go in and add some loops in here. Okay. Hit the 3 key, render again, and we're off and racing. Okay, this is the power of working within sub-Ds and Mental Ray. Okay, it really makes it gives us a really fantastic organic workflow. Okay, so Mental Ray has a lot of rendering features in here that are going to make your images, well, just about awesome. We're going to be looking at each one of these features in detail over the next 3 or 4 weeks, but I want to at least kind of get you started. Okay, so you can start making some pretty pictures. Okay. Because this is still kind of ugly for us. Let me zoom out some. And here's what I'm going to do. I'm going to just add in a unit primitive plane to my scene. Of course, it would help. Excuse me, my allergies are just all of a sudden decided they wanted to start raging. Is anyone else cursed with really bad allergies? I am. I'm cursed with bad allergies, so many apologies. So it looks like I have like a really weird like chess piece or something inside of my scene. And let's do this. Oops, excuse me. There we go. Let's kind of pull my plane down a little bit. I'll make it a little bit bigger as well. And let's use this. Okay, now I'm being a 3D modeler. All right. So if we take a picture as is with Mental Ray in tow, this is what we get. Okay, if you compare and contrast just the quality of the renders between the different rendering engines, at the defaults, without adding anything, they're pretty great. Mental Ray is of much higher quality, okay? Maya software is pretty low end. Mental Ray, pretty high end, okay? The quality is going to be pretty neat. Let's go in real fast, and let's add a directional light. Actually, we're not going to add a directional light because there's one cool thing I want to show you, okay? I got a little ahead of myself. Mental Ray comes with some really great scene properties that we can change inside of the render settings themselves. So as a reminder, I just went into the render settings, the gear icon, and I've transitioned over into the scene tab. Now here's where I'm going to go. I'm going to go into the environment section. And I'm going to create a physical sun and sky. This is all we're going to do. I just want you to hit the button, okay? Because this kind of opens up a whole series of options and nodes inside of Maya that allows us to change how this looks, okay? Let's just render now. Just with that one button enabled, it takes much longer to render, okay? Boom. Say again? So it's under, let me go back into our render settings. So it's under the Scene tab. Once you have Mental Ray enabled as your rendering engine, get the Scene tab. And where I went was under the Environment section. Create Physical Sun and Side. I've already have one. It'll say Create for you if you don't have one yet. Okay. And what this is going to create inside is going to create a directional light, the whole series of input nodes. On that directional light, if you continue the input nodes in your attribute editor, you can get some really great. There's this one called Physical Sky 1. I apologize for my screen getting cut off, but this is where you can go in and you can change a number of different things like the color and the horizon. It's actually trying to do its best to simulate a real world light, which is kind of neat. A real world sun. Use background. If you have a background image, you can change that as well. So we'll be talking about this in the future. But at the very least, I wanted you guys just to go in and turn it on so you can start creating some really pretty pictures. Okay. It does take a little bit longer to render, but as you can see, the results are pretty fantastic. Okay. Now it's beginning to look like it's outside. Okay. And as a reminder, it really is, if you grab that sun direction, you can start going around and tweaking this. Okay, so this is going to determine the angle of the sun. So if you wanted to be a little bit more, high angle like that, render again. You can change the shadow qualities and the shadow placement just by changing the location of that light. Okay? All right. All right, questions on, at the very least, how to turn on physical sun and sky. We'll be talking more about this going forward in the future. We have an assignment where we're going to be building a house. I think it's next week, actually. We're building a house. And as one might imagine, this little doohickey is going to come back and play very quickly when we start rendering exteriors. But I wanted you to at least turn it on for this week's homework in lab. Start playing around with it, as they say. Yes, ma'am?
I downloaded the mental ray.
Did you run the installer?
Yeah.
Okay.
This one, right?
Does this say Maya to MR?
Yeah,
Yeah,
TOM.
that's it.
Yeah, but I can click the
Okay, and then also hit
auto download, but
auto load.
I cannot
Uncheck,
click the lower.
uncheck the other one. Now check loaded.
Still, I cannot.
Okay, do auto load and restart Maya.
And then restart.
Restart, yeah. It should automatically load the plugin going forward. Should. Okay, real quick. Let's go back to Canvas for a second here, and look at what we're going to be building for our lab. Okay, so we're going to be building a little medicine bottle, and as you would imagine, I want you to use subdivision surfaces throughout the entirety of this object. Okay, focus on trying to build the inside and the outside of your little medicine bottle. If you start to explore the transparency values associated with the material, you may be able to generate some pretty cool effects. Okay, but in order to get the well, let me take a step back. We have to construct a complete bottle, the inside and the outside and the lid. I've given you some help here. I've given you this really great medicine bottle template. If you download that and load it in as a backdrop item or an image plane inside of your viewport, it will help you very easily construct this object. Okay? Using our traditional box modeling method, I want you to build this medicine bottle. However, be creative. Okay? Be creative. Think of a cool way to make a picture. It's not just about the bottle. We're also making a picture. In the past, what folks have done, which is I think is kind of cool, they've also they've had the bottle tipped over, and then they have little capsules for pills and stuff that have come out of the bottle. So make a cool picture here. Make some artwork based with the tools that we have in play here. But we want to use subdivision surfaces throughout all of it. Almost kind of going forward, gone are the days where we see polygons. Subdivision surfaces allow us to use our traditional polygon creation tools, but hitting that little 3 key allows us to very quickly transform it into something of much higher quality and resolution. Make sense? Everyone kind of getting it, understanding it? All right, let's get to work. So we got about an hour left in class. You probably can bang this out in class. I have one more thing I want to talk about before we escape today, and that has everything to do with what's going to happen on Thursday. Okay? So let's get to work. I'll walk around and help you guys out. Give me 2 seconds. I'm just going to stop the live stream.